Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about how to run explain on a normalized query from pgstat statements and how to get the generic query plan. This blog post by Frank from Yugabyte talks about how you can get an explain plan from a query that you found in the pgstat statements. If you're not familiar with pgstat statements, it gives you a view of all the queries that have run on your database. That is very useful to get an understanding of what your query workload looks like on a production system. One important thing to know about pgstat statements is that it does normalization. In this example, Frank does a select on this table and, for example, select from demo where I is 42 and t is x. The I equals 42, for example, got turned into I equals $1. This normalization initially didn't exist in Postgres. Initially, pgstat statements actually just record the full query text and then led to all kinds of problems. The first thing that happened is that Peter Gagan improved this in Postgres 9.3 by adding this normalization logic. But initially, this was using question mark characters. And you might not notice, but question mark is also a valid operator in Postgres. Now, I have two fun facts for you today. Fun fact number one is I actually contributed a patch to Postgres a couple of years ago that changed this. The idea was instead of recording these question marks, we would record $1, $2, and such, the same way as prepared statements use them, so that the queries are usable and its ambiguity with the question mark operator is gone. Tom Lane committed this to Postgres about 5 years ago based on that patch. You can now make sense of the queries because they look pretty much like a regular prepared statement. But when you run explain, you will see that it will error out with the error, there is no parameter $1. Postgres tries to interpret this query. It sees that you're referencing a parameter here, and it doesn't know the value of that parameter, and so it can't run explain for you. What Frank does here is he actually prepares that statement. He does prepare test and then puts in a query. When you create a prepared statement in Postgres, it looks at the query and it determines the parameter types for the individual parameters. Even though you haven't actually passed in a value, Postgres knows that this $1 parameter here is most likely going to be a big int, because the I column is a big int. Similarly, the T column is a text, and so it assumes that the $2 parameter is text. That's actually very useful. We'll come back to that later. Now, I don't know the value. Maybe I can just explain the statement by passing null. And unfortunately, null is not the same thing as you don't know. Null does have a distinct meaning to the planner. For example, here, the Postgres planner will return you a result node, meaning it doesn't actually do any lookups on tables. You're passing in null as the primary key. That's impossible. There's no row that would fulfill such a requirement. And so that's why it says, well, I'm not even going to look at the table. Clearly, this is not the actual query plan you would see typically. There are a couple of ways to work around this. First, Frank would try to run a statement 5 times. The reasons for that is in prepared statements in Postgres, if you run a statement a 6th time under a certain condition, Postgres will actually switch to the generic plan, which is the plan that doesn't depend on the actual values. There is some subtleties in when that works, and it really comes down to how Postgres costing works. Here you can see this is a generic query plan that we want to get, which it does an index scan it. Now in Postgres 12, there is actually a new option called plan cache mode. Plan cache mode lets you force the query planner to use a generic plan always. If I pass null here, Postgres says, I don't know the values, I'm going to force that generic plan. This is very useful because you can get a good understanding based on this pgstat statements query. Is there an index that covers that query? Before Postgres 12, there is a couple of hacks, and what Frank describes here is a hack using the CPU operator cost. But there is actually a better way, and this is fun fact number 2 for today, which you might be surprised by that exists. I found this a couple of years ago in the Postgres FDW source code, and there is a way to trick the Postgres planner into unknown constant value. You do this very obscure subselect, which essentially takes a null, casts it to a certain type, and then for certain grammar reasons, casts as a type again. We can actually see that if I run the query that Frank had in this example, I get this result filter. Now, I have to get a little bit creative here. I went into the initial query and I replaced the $1, the $2 with those special subselects with null. I actually get the generic query plan without having to force generic plan. Now, this is immune of Postgres, so I could also do the other option here, and that also works. If you're in a newer Postgres version, I would recommend using the plan cache mode setting. In conclusion, this is a way to get from pgstat statements to a generic explain plan. Now, this may not be the exact same explain plan than what you would get if you pass in an actual value. And so on a production system, if you can, I always recommend enabling auto-explain or collecting actual query samples using log iteration statement, because then you know the actual query plans, and that's going to be much better quality than a generic explain plan. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.